Hello everyone, I'm Tenzihao from UESTC. Today I will share my research titled Dynamic Precoding for Near-Field Secure Communications, Implementation and Performance Analysis. My presentation is divided into 4 parts, which are background, system model, the precoder design for secure communication, simulation results, and conclusions. First is the background. The 6G generation networks rely heavily on the deployment of extremely large-scale antenna arrays. By applying ELAA interior frequency bands, the Fraunhofer distance, which is used to distinguish the near field and far field, will be increased by the order of hundreds of meters. So, 6G wireless communications will mostly occur in the near field. The planar waves became the spherical waves, and the beam steering becomes beam focusing. The native choose worthless is also an important pillar in 6G communications, which requires the physical layer security techniques to safeguard the communication. Most existing PLS techniques were proposed for the far-field scenario, so it fails to guarantee the security when the user and eavesdroppers are in the same direction of the base station. In sharp contrast to the far-field beam steering, the beam focusing allowing for enhanced multiple user communication within the same angular direction. So, it can be used to enhance the physical layer security, and it can keep the secure when the user and eavesdroppers are in the same direction. But the beam focusing requires the eavesdropper CSI at PS, and it has a high computational complexity. Based on this, we propose a dynamic precoder design which has a low complexity and does not require the CSI as a BS. Next is the near-field channel model. We consider a downlink MU-MISO NFC system with a hybrid precoder. The precoder is combined with the dynamic digital baseband precoder and the analog RF precoder. And the total number of antenna elements is N. And the total number of RF chains is NIF, and we consider M legitimate users and Q eavesdroppers. And here are the received signal at the key slot of the M's legitimate user and Q's eavesdropper. And the dynamic baseband precoder can animating inter-user interference for legitimate users and generating distorted constellations at other points in the near-field region. Now I will introduce the precoder design for secure communication. The precoder is combined with the static analog precoder and the dynamic digital precoder. The analog precoder can be designed by the singular value decomposition of the channel metric. And the dynamic digital precoder can be designed by the combining of the GI precoder and the dynamic artificial noise at the key slot. And the AI injection can be designed to use the form with 2 components, which has a positive constant related to security capacity. And we need to maximize C with power constraints. And this problem is difficult to solve at each time slot, which has a high computational complexity. So we use a time agnostic upper bound instead, which has a low complexity. And the random phase of each entry is mutually dependent and uniformly distributed, which is used to create the artificial noise to keep the physical layer security. Next is the simulation results. We consider the ELAA operates at a carrier frequency of 28 GHz, which consists of 40 times 40 elements and has an inter-element spacing of 0.5 lambda. It can be seen that in the left figure, the constellations received by the eavesdroppers are completely scrambled, while the legitimate user can correctly decode the transmitted signals. And a significant reduction in BER for legitimate users and as the average SNR increases, which can be seen in the right figure, while eavesdroppers consistently endure much higher BERs. Next, to showcase the advanced security features of our method, we draw the security map for 3 different area elements. It can be seen that the security outage probability near user 2 is close to 1, primarily due to the higher signal leakage in that region. In contrast, the security outage probability in other areas is relatively low. As the number of antennas increases, the beamforming becomes more focused on user 2, thus reducing the region with a high security outage probability. Next is our conclusions. We propose a hybrid dynamic precoder design algorithm for near-field multiuser PLS. The dynamic hybrid precoder consists of a static analog precoder and a dynamic digital precoder. The static analog precoder is used to reduce the number of RF chains, while the dynamic digital precoder is designed to suppress inter-user interference and generate AN. The numerical evaluations demonstrated that the proposed algorithm effectively enhances security across both angular and distance dimensions without eavesdroppers CSI. That's all. Thanks for your listening.